What if I told you there's a hidden code, a single instruction written into the very fabric of our universe? An elegant blueprint that shapes the curve of a seashell, the awesome power of a hurricane, and even the majestic swirl of a distant galaxy. Well, today we're going to crack that code. So to understand this code, we first have to actually see the pattern. And it turns out our universe has a favorite shape, a shape it uses over and over again. Take a look at the chambered nautilus, deep in the ocean. For millions and millions of years, it has built its home by following this incredibly precise spiral. As the little creature inside grows, the shell expands, but the proportions, the actual shape, stay perfectly, beautifully the same. Now, we see that same pattern scaled up to a totally terrifying size: a hurricane. Its coiled bands of clouds and rain are just a massive version of that same mathematical idea, a vortex of incredible energy, all spinning out from that calm central eye. Okay, so now let's zoom out. I mean, way out. To the grandest scale we can even imagine. A spiral galaxy. Its arms are filled with billions of stars, all sweeping around a glowing core in that same unmistakable shape. A shell, a storm, a galaxy. I mean, think about it. 3 completely different things on wildly different scales, and yet they all share the exact same geometric form. How is that even possible? Could there be a single, hidden blueprint that connects every single one of them? Well, the answer, pretty remarkably, is yes. And the clue to this blueprint isn't something we find in biology or astronomy, but in the purely abstract world of mathematics. And the clue is this one formula. An equation so profound, so beautiful, that the great physicist Richard Feynman called it our jewel and the most remarkable formula in mathematics. It holds the secret to circles and, as we're about to see, the secret to spirals too. And here it is, Euler's formula. Now, I know, at first glance this might look a little intimidating. You've got E, this imaginary number I, sine and cosine all jumbled together. But trust me, the idea behind it is surprisingly simple. And it all comes down to a whole new way of thinking about growth. To unlock what Euler's formula is really saying, we need to wrap our heads around a kind of bizarre but beautiful idea, the concept of imaginary growth. Let's just break down the left side here, e to the power of ix. So think of e as just the universal speed limit for continuous growth, like in a bank account. X is just how long you let it grow for, but I, that's the magic ingredient. The imaginary number I tells our growth to do something completely unexpected. Okay, so normal, real growth pushes you forward, right? In the direction you're already going. It makes you bigger. But imaginary growth, it's like having a little jet engine strapped to your side, constantly pushing you sideways at a perfect 90-degree angle. It doesn't change your size, it changes your direction. So if something is constantly pushing you to the side, you can't go in a straight line, right? You're forced into a curve. This continuous sidewise push doesn't change your speed at all. It only ever changes which way you're pointing. It makes you turn. So Euler's formula is basically telling us a little story. It says, start at the number 1. Then apply this continuous imaginary or sideways growth for X amount of time. The path you end up tracing, it won't be a straight line getting bigger and bigger. It'll be a perfect circle. And that's the first secret. E to the power of I is just the mathematical code for pure rotation. So, okay, we've figured out pure rotation. But those nautilus shells and galaxies we saw, they aren't just spinning in a perfect circle. They're also growing outwards at the same time. And that brings us to the second secret. So the natural next question is, what happens if we do both? What if we have one engine pushing us forward, making us bigger, and that little engine on our side pushing us sideways and making us turn, both firing at the exact same time?
The math gives us a super simple way to combine these two ideas. We just add a real growth part, let's call it A, to our imaginary rotation part, B. So now we have 2 commands happening at once. The A part is saying get bigger, push outwards, while the B part is saying turn, push sideways. And the ratio between that A and B, that's everything. It controls how tight the spiral is. A big A gives you a wide sweeping spiral, like a galaxy. A smaller A creates a much tighter coil, just like our nautilus.
And the result of combining these 2 commands is, well, it's magical. That pure rotation of the circle is broken. As you turn, you are also being pushed outwards. The perfect circle unwinds into this elegant, ever-expanding spiral.
And with that, we found it. We have the blueprint, the one that connects the shell to the storm and the storm to the stars.
This simple little expression, just describing growth that happens forwards and sideways at the same time, is the mathematical DNA for one of nature's most iconic shapes.
It's the reason a nautilus shell can grow outwards, but always, always maintain its perfect shape. The shell itself is a physical record of this complex growth in action.
And then, what's really mind-blowing is that the same code, just with different settings for growth versus rotation, is what governs the dynamics of a hurricane and the majestic sweep of a galaxy. It is a truly universal blueprint.
You know, this shape has fascinated mathematicians for centuries, long before we even knew galaxies existed or understood the physics of a hurricane.
There was this 17th century mathematician, Jacob Bernoulli, who was so obsessed with its properties that he gave it a special name, Spira Mirabilis, which means the marvelous or miraculous spiral.
He was just captivated by this idea of self-similarity, the fact that as it gets bigger, its shape is totally unaltered. He actually thought it was a symbol of resurrection, and he asked for this very spiral to be engraved on his headstone with the Latin phrase, "Although changed, I shall arise the same."
So, a simple idea, growth that just goes sideways, unlocks the blueprint for the circles and spirals that help define our universe. It really makes you wonder, what other cosmic secrets are just sitting there waiting for us to find them, all written in the universal language of math?